Hey everybody, Algebra 2, Lesson 1-7, solving linear systems of equations using matrices. And you're going to use the reduced echelon form in order to do that. So some of the properties or the things you can do is, in this first example, you can just have the rows trade places. In the second one, you can multiply a row by any number. Here they multiplied the second row all by a 2. And the third one, you can add 2 rows together. So they added the 2 and the 5 and got the 7. The 3 and the 2 came up with a 5, and the 7 and 9 to get this 16. So and then the bottom one, notice the way if you can get it in this form where there's a 1 in the first spot, and then as you go down, they progress. Okay, so when you do that, well, you'll see when we get to it, then you can pick out the answers to the whole system. All right, this just repeats the same thing. So looking here at this example, there's the original. Notice they multiplied the top row by a 2, bottom row by a 3. They wanted to get these 6s in the same spot. Let's see, I'm gonna see if I switch my tools here, if I can get this to work better. So multiplying by a 2 here makes this 6. 2 times this 2 makes this 4. And 2 times that 25 makes this 50. In the second row, multiply by 3. So that 3 times that 2 makes this 6. 3 times this 5 makes it. And they're trying to get these two first numbers the same. So when they subtract these, 6 minus 6, they get 0. Negative 4 minus 15 is negative 19. And then 50 minus 12 is 38. And then they copied the second equation still down below. So in the reduced echelon over here, you can see what they did. They multiplied the whole rows, and you can see what they're getting there. And then when they subtracted, they're getting a 0 in this first spot. So zeros, 1's in the diagonals, 0's in the other spot. So right here, they've got a 0 and then the next thing is they want to turn this 5 into a 0 now. So they're going with the zeros in these diagonals. So if I multiply the top equation by a negative 5 times this 1, that makes this negative 5, and negative 5 times this negative 2 makes this 10. Now, when I add the 2 rows together, negative 5 and 5, that makes this 0. And then 0 and 2 leaves a 2 here. And 10 and 4 makes this 14. But now the next step is we want 1s where these numbers are, where the zeros are not. So if you divide the top one by 5 or multiply by 1/5, so that 1/5 times this would be a negative 1/5 to make that a positive 1, and negative 1/5 times 10 makes this negative 2. And then divide these by 2 or multiply by 1/2 there. So you get 1 in this spot, and then keep that 0 in the 14. Then they just changed the order here so that you could have your x being the 7. And this 1 here is your y being negative 2. But I'm also going to show you how to do this in Desmos so that you don't have to actually you don't have to do it by hand. As far as I'm concerned, you are more than welcome to use the Desmos matrix calculator. So let's see if I can share that screen with you. And we're going to start at desmos.com. And then when that opens up, you can go to the graphing calculator if you would like, but there's also in the math tools, there's the matrix calculator. It'll take you right there. And so that problem that we were just looking at that had 3, -2, and 25 in the first row. Let's see if I go back there. Let me write that on the screen. I think it'll stay over when we go back to Desmos. Let's see. Get on the right screen here. Here's your original problems there. And again, we had 3, -2, and then they call this an augmented matrix on the right side's the answers. So this 25, and then the other one was 2x, 5y, and a 4. All right, and so now when we go back to Desmos, and I'll show you how to put it in there, and you don't have to do that whole reduced echelon form where you're getting the ones and zeros all through the matrix. So you click on new matrix, and it's 2 rows and 2 columns. That's what we've already got down here on the bottom. And then, oh, my numbers went away. I thought they would stay on the screen. I have to get a piece of paper and write those down, or let's see, I can jump over there and look at it again. It was 3, -2, 25, 3, -2, and then the second row down here is 2 and 5, 2, 5, and then I add another matrix. It's going to call it B, I think. This is just for the answers on the right side, so it's 2 rows but only 1 column, and I just do my answers from the right side of the problem, which they were 25 and 4. So 25 and 4. And then we go and we do a calculation on here. The calculation goes like this. I take my A inverse matrix. Oops, let's get the A first. A, put the inverse on it. And then I take that times the B matrix, and I hit enter, and the calculator does all the work. Tells us over here on the right, the answer was 7 and -2. So if we go back to that other screen, where we were working, you can get your answers of 7 and -2. And there you have it. So 2 different methods you can use, or you can do it just by hand, like the left side here. I like the matrices where I get to use the calculator. The only people that really even need to know how to do all of this matrix work is the person that's going to program the computer to do it for me. So hopefully, I think that may be everything that we really needed for most of this lesson. So there's a couple of them we could practice on. The reduced echelon, this is again showing us we want ones through all those diagonals. And yet, if we just start with this problem down here, with the 1, 1, 2 augmented on the right, 13, we're going to put that in a separate matrix, 5 and 6, and then the 0, 2, 1, and the 2, -1, 0. That's the coefficients here. 1, 1, 2. That's the first row. 0, 2, 1. If there's no number, that's the second row. 2, -1, 0. And then again, let's go back and practice. See, we could follow this one through with what they did. And you can see when you look at these pages, they go through all of the steps to solve it. And you can also do it by hand with a system of equations. But let's go back to Desmos, and again, we'll enter this one. So let me bring Desmos up here for you. And we'll get rid of these. There was an all clear button here somewhere. I don't see it. Well, let's make this into a 3x3 and we'll just use these. So let's see. Again, my original problem in the first row, it was 1, 1, 2 with an answer of 13. So 1, 1, 2, 1, 1, 2. And then down here, the answer in that first row was a 13. I need one more row there. The second row, when we were on that problem, if you're not sure where I'm getting this, let me show you again. It was these 3 problems that we're doing right down here. 1, 1, 2, 0, 2, 1 with a 5. So I'm going to go back to that Desmo, 0, 2, 1, 0, 2, 1, and the answer had 5 in it. And then the last row, down here on the bottom, down here is 2, -1, 0 with the answer of 6. 2, -1, 0 with an answer of 6. Two, -1, 0, and down here an answer of 6. And now if you just are careful, all you gotta do is be careful to type it in correct, because the technology will do the answer. I got my answers of 3, 0, 5, and we can go back and look and see what they came up with when we look at those slides. 3, 0, and 5. Let's take a look here and see what they said when we went over here. Look all the way down through all these steps to get the ones in the diagonal. That's our final objective again on these, is we want ones in the diagonal, everything else 0, 3, 0, 5. And that's going to end up giving us our answer to the entire problem. But again, it's just looking again, and then here they did a check step to see, do they work, the 3, 0, 5, 3, 0, and 5, and put them in to see that it does work in each of the equations. Again, we could do a try it to practice, or they're showing you another different, this like a graphing calculator look of how the matrices might show up depending on what your technology is. And then if you have 3 variables and you have an X, Y, and like a Z, this is demonstrating that you might have 3 dimensions you have to graph in. Like, it's a little trippy. And putting it into a word problem where they have a story that it has to fit with. But that's a quick overview. There's lots of videos out there that explain it in much more detail. But again, I'm going to let you just use the Desmos matrix calculator to solve these. Do it by hand if you want a challenge, but that's just there's so much arithmetic you have to do, and it's so easy to make a mistake and then basically do it all right, but get it wrong. All right, good luck.